This video will provide a video tutorial of how to use the combination and binomial distribution formulas in Excel from Chapter 5. So here we've got our example from the lecture. A bank believes that 80% of its customers prefer the bank to close early on Fridays and be open on Saturday mornings. Suppose 8 customers are randomly surveyed and the binomial distribution applies. So the first formula that our text offers us is the combination formula. This will let you figure out how many ways or the count of an event that can occur. So let's look at our formula. We see it starts with combine, and then there's number and number chosen. In other words, number is our n, and number chosen is our variable of interest. So if we look at our problem, we can see how many ways can 3 of the customers surveyed respond that they like Saturday mornings opened. So there our n is 8 from the problem, and x is 3 customers agreeing to Saturday opening. So let's go ahead and plug that into our formula. Type in equal and then combine, and you'll notice that Excel will try to pre-populate what they think you want. Make sure it is the one that you are interested in, or you can type it out fully. Type parentheses start, then the number, in this case n equals 8, comma, our number chosen is 3 customers saying yes to Saturdays. Type in 3, and then close your parentheses and hit enter. You'll see that there are 56 ways that 3 out of 8 customers can agree to a Saturday opening. Let's move on to the binomial distribution. Here you'll see that there's 3 types of formulas that we can use that will let us figure out the binomial distribution of a variety of scenarios. So it starts with binomial distribution, and you're looking for an x, an n, a p, and this last part will determine whether your data is cumulative or not. So down here at the bottom, I've defined what each one is. False means not cumulative, which is used when you're trying to find an exact number, an exact x. True is used or meant cumulative and is used to find x or fewer. And when you want to find x or greater, you're going to do 1 minus the formula that uses true. So it's the complement of the above formula. So let's go ahead and look at some scenarios. So first here, what is the probability of exactly 3 customers in a sample of 8 who prefer Saturday openings? So we know that we're looking for an exact number. We'll make sure to use the word false. So here our n is still 8. Our probability, or our p, is still 0.8, or the 80% from the word problem. And what we're interested in is the probability of exactly 3 customers. That's the p of x equals 3. So let's go ahead and type in our formula. So we'll do equals binom, and you'll see again it tries to pre-populate. We want the distribution one. Our number, or our x that we're interested in, is 3 customers. The number of trials, or n, is the 8 randomly selected customers. The probability from the problem was 0.8, and because we're doing an exact number, we'll type in the word false. Okay, and then go ahead and hit enter. So the probability of exactly 3 customers in the sample of 8 who prefer Saturday openings is 0.0092. Let's go ahead and move on to the next scenario. Here, our question is, what's the probability of 3 or fewer customers in a sample of 8 who prefer Saturday openings? So we know our n is still 8, our p is still 0.8, but now the probability that we're interested in finding is x is less than or equal to 3. What I've done below is I've also written a few other ways that the problem could state the same thing, right? Fewer than 4 customers, less than 4 customers, at most 3 customers. These different ways of writing it all say the same thing, which is we want to know the probability where x is less than or equal to 3. So here you have to apply critical thinking to interpret your problem so that you can set up the appropriate probabilities. So let's go ahead and plug in what we want to know. So again, we've got our equal sign binomial distribution, and because we recently used it, you can just select it again. Our x, in this case, is, let's see what it was asking for, 3 or fewer. Okay, so 3. Our n is still 8. Our probability is 0.8, And because we are looking for 3 or fewer, that would be cumulative, we will type in the word true. So that will give us the probability where 3 or fewer customers in the sample will prefer a Saturday opening. Now let's go ahead and do the last formula. Here in our scenario, it asks what is the probability of 4 or more customers in a sample of 8 who prefer Saturday openings. Our N and our P are still the same, but our probability is now X is greater or equal to 4. Again, below in italics, I've offered other ways to say the same thing, right? 4 or more customers can also be written as more than 3 customers, at least 4 customers. And so again, when you're reading the problem, you're looking for these clues to tell you which way to set up your equal or greater than or less than symbols. Okay. Now also remember that when we're working with some number or greater, we have to, just below you see here, it says 4, where the probability of X is greater or equal to 4, we have to use 1 minus the probability of X is less than 3 or equal to 3. So what that means is when I type in my X in this formula, I'm using one number less than what I'm actually interested in. Since I want to know 4 or more, I'm going to type in 3. So let's go ahead and do that. You do equals 1 minus binom, and it still will pre-populate for you and give you your parentheses, so that saves you some time. In this case, X is 3, our N is still 8, our P, 0.8, and we'll type in the word true. And when you hit enter, that'll give us the probability of 4 or more customers in the sample of 8 who prefer Saturday openings. Now remember, again, we were asking for 4 or more, but for the formula to work, we used 3. So we're going one number less than. Okay. Hopefully that makes sense. If you've got questions, let me know. But that's how to use the combination and binomial distribution formulas.